Okay, so on this question, they give us this function and they ask us for the first derivative. So let's do the first derivative. So f prime of x, bring the 3 on down, be 6x squared, bring the 2 on down, 6x, the 1 power comes down, and then it's minus 1. So that's just gone, and the 18 is just gone. So there's the first derivative, as we see. Then they want us to list the critical values. So that would be, bring it down here. Um, so we take that first derivative, and I'm going to factor out the 6. And we're going to set it. Oops, scribble it there. Scribble. Set it equal to 0 because that's how you find critical values. It's when f prime is 0 or infinity. Okay, so then how do we finish that? Well, that's going to factor. And remember, it's like FOIL. We go front times front to make front. That's x and x. Last in this parenthesis times last in that parenthesis to make 2. Don't worry about the negative. Just go 1 times 2, 2 times 1. The order doesn't matter, but the signs do. How do you do the signs? Whatever's in the middle goes on the bigger. Yeah, there's going to be negative. And that works because plus 2 minus 1 makes plus, really, this is 1 in the middle. And they multiply negative 1 times plus 2 to be negative 2. All right, so then you said each one equal to 0. Now the 6, you said each part equal to 0, right? 3 things are multiplying to be 0. But the 6 doesn't have an x. So he can't make anything 0. He doesn't have a variable. Is that making sense? Right? Logically, you understanding that? Plain old 6 times something is equaling 0. That just means one of those two things that can vary is 0. So then bump that over, bump that over. We just ignore the 6 plus 1 minus 2 because the 6 has nothing to do with the logic. Again, if I told you, hey, I'm thinking of two numbers, 6 times the first number times the second is 0. What does that mean? This number could be 0 or that number could be 0. It doesn't mean anything about 6, right? Because the 6 doesn't have an x. So it can't vary. It doesn't have a variable. It's just 6. It's never going to be 0. But these two guys have the ability to be 0 if x is 1 or negative 2. So those are our critical values. Put them in either order. Now they want us to find increasing, decreasing. Remember, increasing is going to be where f prime is positive and decreasing f prime is negative. So we got to do like a little number line thing for f prime. So I'm going to put these on the number line. So I'm going to go negative, put them in their real actual order. So this will be, well, that's a little bit, give it a little more room here. Like this and like that. We're going to put negative 2 and positive 1. And we get to check some point over here like x equals negative 3. Something in the middle like x is 0. And something over here like plus 2. So we're going to check each of those intervals to see if it's increasing or decreasing. Let me check the first derivative. So I'm going to check the first derivative, which is 6. I'll use the factored version. Either one would be fine. So, or maybe, so I'm going to plug in negative 3. Let's go to where I did that. Oh, it's not this one, it's this one. Okay, actually, I did the original one. So I got 24. So I plugged in negative 3, got 24 there. Got 24. Yeah, it doesn't matter which one you use. I actually ended up using the original, whatever. It doesn't matter. I did, I think I actually just used this 6x squared plus 6x minus 12. And I plugged in the negative 3. Okay, and then we're going to do it here as well. What's f prime? Plugging in 0. Let's go plug in 0 to the same derivative now. Plug in 0. 0. What do we get? Negative 12. And then plug in 2. we get 24. So that means this is an increasing, graph's going up, decreasing because it's negative, graph's going down. This one was positive. And then this one is also increasing because it's positive, graph's going up. So we're getting up, down, up. And so, oh, and they want the, where's it increasing? So this goes from negative infinity up to -2 is increasing, and increasing is also from 1 to infinity. So we get -infinity to -2, 1 to infinity. Then for increasing, and then decreasing is -2 to 1. -2 to 1 is the decreasing section. So we get that. Right, they want the second derivative. So I'm going to take that first derivative. Separate things. Okay, so I'm going to take my, what was the first derivative again? First derivative is right there, 6x squared plus 6x minus 12. And I'm going to do the second derivative. So here we go. Second derivative, bring it down. 12x, bring it down. Plus 6, that's gone. And minus 1 on the power, so that x is just gone. Okay, there's the second derivative, 12x plus 6. Got it. And then they want to identify max and min. So that's easy. If we go back to this part here, let me do it with this color. Okay, it's increasing. So the function's going up, right? Increasing. Then it's going down, decreasing. Then it's going up, increasing. So this must be a max, and this must be a min at +1. So max at -2, min at +1. Max at -2, min at +1. And then finally, they want concave up, concave down. Well, that's the second derivative positive for concave up and second derivative negative for concave down. Oh, and then we have inflection as well. Okay, so how do we get that? Well, we got that second derivative, so we got to do another number line now for the second derivative situation. So, and actually first, we're going to have to set that equal to 0 and find where the second derivative is 0. So so bump this 6 to the other side. 12x is -6. Divide by 12. So x is minus 0.5. So there we go. So x is minus 0.5. So then I'm going to have a checkpoint, like something like -1. And then something over here like 0. Because -0.5, that's going to be where the second derivative is 0, right? I took the second derivative and set it equal to 0, and that was -0.5. So then this side's going to be positive or negative, vice versa. So it's 0 right here. So whenever you want to find where things are positive and negative, you first find where they're 0, and then you check around it to find the positive and negative. So I'm going to plug into what? I'm going to plug into the second derivative. Second derivative, which is 12x plus 6. I'm going to take that -1 and plug it in. Same thing here. Second derivative, 12x plus 6. Take that 0, plug it in. So 12x plus 6, let's plug in -1. I've already done that right here. 12x plus 6, plug in -1, comes out -6. First one comes out -6. -6. And then this one, plug in 0. And we get 6, +6. So that means it's concave down in this section and concave up in this section because it's positive here, negative here. And that means right there, right in the middle must be an inflection point. Right, it inflects, it changes its concavity from bowl down to bowl up, right there where the second derivative is 0, right? Because it's bowl down, negative concavity, bowl up, positive concavity right there in the middle, inflection point. So there's the rest of the question. So it's concave up from -0.5 to infinity, right? This goes from to infinity. So it's concave up from -0.5 to infinity, concave down from -infinity to -0.5. It's the same negative. 0.5. That's the answer we got right there. Concave up, -0.5 to infinity, concave down, -infinity, 8.5. The inflection point is -0.5 for x. And there we go. That was a lot of stuff. We found it all.